Hello everyone and welcome back to our channel. And in today's video we'll be talking about the chain rule, and it seems that the definition of the chain rule is very complicated, and right here you will see the very detailed definition of the chain rule. And I know that some of you may interpret this one as a very complicated rule to follow, especially in differentiating different functions, but we will make it simple by using only 3 steps. But before going to some examples, I have here some remarks for you. Take note that chain rule is used in differentiating composition of functions or a function within a function, and it is very important also that when dealing with composition of functions, you know the inside function and the outside function. And after that, you may follow this 3-step chain rule method that we'll be using to solve functions that requires chain rule. So the first step is to derive the outside function with respect to x, but don't write x. I'm assuming that you know already the different differentiation formula, like the simple power rule, the product rule, the quotient, and addition and subtraction of functions and their corresponding techniques on how to differentiate them. Okay, and I'm also assuming that before you derive the outside function, you have already identified the outside function, of course, and the inside function. Okay, and step 2, where x goes, write the inside function, and lastly multiply the derivative of the inside function and then simplify. So we could summarize this very complicated looking rule here that defines the chain rule method by these 3 steps. And I know that this will be very clear when we have our example. Okay, so let's get right into the show. We have here example number 1. I have prepared here a very simple example. Okay, so the first one is find the derivative of this function y equals the quantity of x squared plus 1 to the 3rd power. Obviously, some of you may be thinking that this could be derived by expanding first the quantity x squared plus 1 3 times, but you know, if you will multiply that 3 times, x squared plus 1 times x squared plus 1 times x squared plus 1, you will have very long polynomials, and you will apply there the rules for differentiation for subtraction and addition. But this time, since our exponent is 3, then maybe we will apply here chain rule and we will have those steps. Okay, so before applying the 3-step formula for chain rule, we will identify first the outside function and the inside function. Okay, so obviously in the given problem, our inside function represented by u is equal to x squared plus 1. Okay, and our outside function is of course equal to u raised to the 3rd power. I changed the quantity x squared plus 1 to u because I have identified that as our inside function x squared plus 1. Okay, so the first step that we should do is to differentiate the outside function, but don't write x. In our case here, we're using letter u, so don't write letter u. So using simple power rule here, we will derive that u to the 3rd, so that will be 3u 3 minus 1. Okay, so this is equal now to 3. We will not write u, and 3 minus 1 here is squared. That is step 1. Okay, and step 2 says where u goes, or where x goes, write the inside function, and our inside function here is x squared plus 1. Okay, so our inside function here, I will write here in the parentheses x squared plus 1. So that is step number 2. Okay, and step number 3, we will multiply all of this by the derivative of the inside function. Okay, so our inside function here is x squared plus 1. So the derivative of x squared is, we know that will be 2x, and the derivative of 1 is 0. So far, that is the result when we apply those three steps in derivation of the given function x squared plus 1 raised to 3. Our last job here is to simplify this result. Okay, so the first simplification that I will do is I will multiply this 2x by 3, so that will be 6x, and then I will have here the quantity x squared plus 1 raised to the second power. Okay, so this is now our y prime, or the derivative of y in the given function x squared plus 1 raised to the third power. Okay, so if you could observe in our first example, the very first step that we did is to identify the inside function and the outside function. The next one is to derive the outside function, and where u goes, to write the inside function, and then multiply lastly by the derivative of the inside function. Okay, so that's the first one. Okay, the second example here is find the derivative of y equals x to the fourth plus 3x raised to the fifth power. And this one will be very complicated if you are planning to expand this one in expand this x to the fourth plus 3x 5 times, then you know the result will be a very long polynomial. So it will take a lot of time to do that, but when you know the three-step chain rule method, then you could derive this one in a short manner of time. Okay, so y prime here is equal to the three-step chain rule, but before that we'll have first the inside function. So our inside function is most probably, these are the terms that you could see inside the parentheses. So this is x to the fourth plus 3x. Okay, so once you have identified the inside function, and the book, your module called this one as u, then your outside function will be that entire inside function, which is represented by letter u, small letter u, raised to the fifth power. Okay, so as you could see, the outside function is u to the fifth, so it's very simple. U to the fifth power is, you can apply here simple power rule, which says the first step is to derive the outside function, so it will be 5u to the fourth power. Okay, and step 2 says where u goes, write the inside function. Okay, so our inside function here is, what's the inside function? Here, the inside function is x to the fourth plus 3. So we will write it here, x to the fourth plus 3x. Okay, and last step, after writing the inside function in the parentheses, we'll multiply that by the derivative of the inside function, which is 4x cubed plus 3. Okay, parentheses if you would like to, and after that the remaining process that we'll do is for simplification. So we could not simplify this to the we could not simplify these terms to what maybe you are expecting to be in your module, but as of this time, the simplification method that we could do is to multiply 5 by this quantity here, so that will be 5 times 4x cubed, that will be 20x cubed, plus 5 times 3 is 15. That whole quantity multiplied by x to the fourth plus 3x. Okay, raised to the fourth power. So far so good. You can stop here, and that's the derivative of y equals x to the fourth plus 3x raised to the fifth power. Okay, I have here a last example, example number 3, and this one is f of x equals the sixth root of 2x plus 1. The problem may seem complicated, but we can rewrite this one to make it simple. So we can rewrite this one as f of x is equal to, how do you rewrite this one? Of course, you know that in advanced algebra how to rewrite this one. 2x plus 1 raised to 1/6, because the sixth root means the index is 6 and the index should go to the denominator, and the exponent here of 2x plus 1 is 1, so that'll be 1/6. Okay, so the inside function now of this expression is equal to 2x plus 1. Okay, and the outside function is equal to u raised to 1/6. Alright, so f prime of x, or the first derivative of the given function, is equal to, first step is to derive the outside function. The derivation of the outside function is 1/6 u, and you will have here 1/6 minus 1, which is, okay, what is the result if we will subtract 1 from 1/6? So I would do the algebra here on the right side. Okay, so what is 1/6 minus 1? So 1/6 minus 1 over 1 is equal to, the common denominator is 6. 6 divided 6 is 1. 1 times 1 is 1. 6 divided 1 is 6. 6 times negative 1 is negative 6, and the result is negative 5/6. Okay, so our denominator here, no, not denominator, our exponent of u will be equal to 1/6 minus 1 is negative 5/6. Okay, that is step 1. Step 2 is, where x goes, we'll write here the inside function, and our inside function is here. Our inside function is 2x plus 1, so I will write here 2x plus 1. Okay, and the last step is to multiply all of this by the derivative of the inside function, which is here in our example is 2. The derivative of here, the derivative of 2x plus 1 is 2 plus 0, of course. I will not write 0 anymore, you know that. Okay, so the simplification process would be multiplying this 1/6 by 2, or you could cancel out or reduce 2 and 6, this one 2 and 6, and that will become 1/3. Okay, 1/3 2x plus 1 raised to the negative 5/6. Okay, and using simplification method in algebra, you could rewrite this one if you would like to go back to radicals. So this will be equal to 1 over, since we have here a negative, so we'll have a numerator of 1, and we'll bring this whole expression in the denominator. So we'll have 3 and the 6th root of the quantity 2x plus 1 raised to the 5th power. Okay, so far this is the simplification using your background in algebra. Okay, so this is now the first derivative of the given function f of x equals the 6th root of 2x plus 1 using the chain rule and the very 3 steps that we have been discussing. Thank you very much, and see you soon on the next video. Don't forget to like and subscribe to our channel, and of course don't forget also to hit the notification bell at the bottom so that you will be updated with the different videos that we'll be uploading in the future. Thank you, and see you soon.